At the end of the last video, I asked you to sketch f of x equals 3 to the x by completing this table of values, thinking about the patterns that are started by those points, and connecting the dots. So remember, anything to the 0 is 1. 3 to the first is 3. 3 squared is 9. The negative powers just give me the reciprocals of those results. So over here, I've graphed this. Here's 0, 1 is my y-intercept. As we go to the right, the function grows and gets pretty steep pretty fast. Okay, notice this is growing a lot faster than 2 to the x was, because for 2 to the x, when x was 2, we'd only climbed to a height of 4. Here, powers of 3 are going to grow really, really fast. Okay. On the left side of the graph, as we move to the left, which of course is backwards, our y values are getting smaller. As a result, the function is always actually increasing when we read it properly from left to right. But these powers of 3 are never going to hit 0, and they're never going to be negative. So once again, we have a horizontal asymptote on the left side of our graph. Now, if I were to graph on the same pair of axes, 2 to the x, I'm going to just graph that in blue really quickly, has the same y-intercept of 0, 1. But at 1 we were at 2, and at 2 we were at 4. So it's the same pattern, but it's just growing not quite as quickly as this is. It's growing, and it's getting steep. It's growing pretty quickly, but when the base is 3, it's growing even faster. Okay. Now on the left side of the graph, at -1 we were at a half, and at -2 we were at a fourth. So there, the smaller base actually gives me a slightly bigger power. So those graphs actually cross at that common x-intercept, so that the smaller base is smaller on the right side of the graph. The smaller base actually gives me bigger values on the left side of the graph, although both of them are giving me very small values. Okay, excellent. So it looks like we're getting the same sort of basic shape, even though we've got a different base. And I could see if I were to do 4 to the x, I expected I would get something similar. It would just be going up even faster on the right-hand side. Okay. But if I remember correctly, the definition of an exponential function was that we were going to have f of x equaling b to the x, where the rule for the base was that it did have to be positive, and it wasn't allowed to be 1. Okay. But that means it can be smaller than 1. It could be between 0 and 1. So I could have a fractional base that's smaller than 1. And I'd kind of like to take a look at what happens in that case. So let's take a look at y equals 1/2 to the x. Let's work through this one together. I'm going to create the same table of values for this. I have x and then 1/2 to the x. And I'm going to plug in a couple of negatives, 0, and a couple of positives. Okay. Anything to the 0 is 1. 1/2 to the first is just 1/2. 1/2 squared is going to be 1/4, because I would square the top and square the bottom. Now notice, if I plot just these points, and we'll come back and deal with the left side of the graph in a moment. Here's my 0, 1. At 1, we're at a half. At 2, we're at a fourth. Now, as I increase the exponent, the powers are actually getting smaller. That's going to be true anytime my base is a number between 0 and 1. Because if I think about it, when I square 1/2, I'm taking a half times a half. I'm multiplying by another factor of a half, but when I multiply by a half, I make something smaller. When my base is bigger than 1, multiplying by the base makes things bigger. But when my base is smaller than 1, multiplying by the base, and I multiply by another factor of the base each time I raise the exponent by 1, multiplying by that base is going to make things smaller. Now, am I ever going to hit 0? No, because I'm always going to have a power of a positive number. So a half times a half times a half times a half a million times is still going to be positive. It's going to be very, very small. And of course, if I have messier exponents that are fractions or irrational numbers, those will just take on y values that are in between the ones that it's easier to calculate. So it looks like as we go to the right, we're decreasing. We're going to have a horizontal asymptote. So the x-axis is still a horizontal asymptote, but this time we're approaching it on the right side of the graph rather than the left side of the graph. Let's take a look at what happens on the left-hand side of the graph. 1/2 to the -1 is the reciprocal of 1/2. I think the easiest thing to do is just say, let's flip it. It's going to be 2. Okay. Now I could say it's 1 over 1/2. But of course, when you divide by a fraction, you flip and multiply. So that becomes just 1 times 2 over 1, which is 2. Again, I think it's simplest to just say, hey, that says take the reciprocal. If I flip a half, I get 2. This says take the reciprocal and square it, or square it and take the reciprocal. You can do it in either order. If I take the reciprocal, I get 2, and I square that, I get 4. If I square 1/2, we just saw that I got a 4th. If I take the reciprocal of that, I'll get 4. So now, it's as we go off to the left that our y values are getting bigger. So there's -2, 4, and here's -1, 2. And that pattern will continue. Because if I have -3, that's going to be the reciprocal of 2 cubed. Sorry, the reciprocal of 1/2, which is 2, cubed. It's just going to be getting bigger and bigger and bigger. So now we've got something that looks like this. Now, its domain is still all real numbers. Its range is still all positive numbers, but this time the function is always decreasing. Okay. Now it turns out all exponential functions are going to have one of these two patterns. The patterns that we saw when 2 and 3 were our base shows us what happens if the base is bigger than 1. This pattern that we get things smaller and smaller and smaller so that we're always decreasing is what we'll have anytime the base is between 0 and 1. So in the next video, we'll sort of summarize that, and then we'll return to that question of why do we have these restrictions on the base, that it has to be positive and that it can't be 1. Okay.